Okay, so this property I'm going to show you is looking at cleavage versus fracture. So as we mentioned before, cleavage is how a mineral breaks along a flat plane, and usually the cleavage surfaces are going to be parallel to each other. So when you're looking at a mineral, what you want to look for are very flat surfaces that are actually going to reflect light, and you want to find a parallel surface on both sides of the mineral. So for example, this mineral sample here shows very, very good cleavage. So you can see there's a nice flat cleavage surface on this side and a parallel surface on that side. And so I can see that this one does have definite cleavage. If I look at the sides of my mineral, I can see that there's a very flat plane on this side, and it's matched with a flat plane on this side. So that tells me that's another direction of cleavage. Then I can turn this around, and I can see here's another flat plane with a matching flat plane on that side. And so this shows 3 directions of cleavage. And if I look at the angle, it's not at 90 degrees. Okay, so it's not a perfectly straight up, straight down 90-degree angle, but it does show 3 directions of cleavage. And so this mineral here, you can see where it's broken, but it's still showing those same planes. So if I can look at this surface, it matches with this surface here. So basically that shows me that's the same cleavage plane. This surface matches with this surface, and so that's another cleavage plane. And so I can see that when this mineral breaks, it breaks along certain directions within the structure of the mineral. So when I break this mineral, it's always going to break in this shape. And so no matter what the size sample is, it's always going to break in these basically directions and these cleavage with these 3 cleavage planes. Other minerals, you can see here's another one. This one actually, if I look at it closely, it also has, it's not showing the third one very well, but it does have 3 directions of cleavage. So I have one direction at the top and the bottom of this mineral. I have another direction, which is the 2 sides of the mineral, and it's harder to see on this one, but I actually have a 3rd direction on each end. Now this mineral, if you look at the angle of the mineral planes, it has a 90-degree angle versus this one, which you can see has a slight, it's not at 90 degrees, it's slightly not 90 degrees. So both of these minerals have 3 directions of cleavage, but they are showing slightly different angles. But this mineral here, if I was to take a hammer to it and smash it up, it would be tiny, tiny cubes because this one has what we call cubic cleavage. Another example of cubic cleavage is this mineral. So here it shows a very strong cubic cleavage here. And so this mineral always basically is found with this. And if I break it, it would actually show that same cleavage. Even when I have a bunch of these little pieces, it's a bunch of tiny little cubes that are basically grown together. So it's tiny pieces of this one. And so this one always shows this cubic cleavage. Other minerals, like this mica, show one direction of cleavage. So I can see that it's very, very flat this way, but on the sides, if I break it anywhere else, it has fracture. But this one is very unique because it has one direction of cleavage, and I can peel it apart. It's very soft too, but I can peel it apart like pieces of paper because it's peeling along that one direction of cleavage. So this is actually one fun to play with. So it shows us one direction of cleavage, but all you can see the other edges are all very irregular, and so that is what we refer to as fracture. So when a mineral does not break along a certain plane, it's what we refer to as fracture. Now some minerals, as you can see, this is fracture on this mineral here. You can see it's a very irregular surface. Now when you look at a crystal form of a mineral, you may think that it's cleavage. But this is actually a piece of quartz, and it's showing the crystals, crystalline form. So these are actually crystal faces of the mineral. But if I was to break it, it's always going to break like this. It's always going to break in an irregular fashion. It's always going to show cleavage. Another example is this barrel, which also you can see has these very nice flat, even though they're flat parallel surfaces, they are crystal surfaces, because if I break it, it does not break along these surfaces, it breaks in an irregular fashion. So sometimes it's very easy to confuse a crystal face with a cleavage plane. So cleavage is actually one of the hardest of all of the properties to identify. It takes a long time to be able to pick out the cleavage. Sometimes it's very, very obvious, but a lot of times it's not so obvious. So cleavage, it can be very difficult to do.